Okay, so in this marking period, we have covered writing and balancing reactions. We've covered the mole, and now we're going to take the two of them together and do it in a unit called stoichiometry. So the first thing I want to talk about is some of the information from the balanced chemical equations that we weren't really looking at before, we were just doing it. So you remember when we wrote reactions like this nice single replacement reaction of sodium plus water yields sodium hydroxide plus hydrogen. And we balanced it, so there are these two coefficients. Well, there's something interesting about each of these two coefficients, and even the one that's in front of the hydrogen. And what we find is this is actually a very specific ratio of the substances in the chemical reaction. Now, specifically, this ratio is in terms of moles and atoms or molecules. So in other words, if I want the perfect ratio of this reaction to occur, I can take 2 moles of sodium and 2 moles of water and I react it and I'll get 2 moles of sodium hydroxide and 1 mole of hydrogen gas when we're doing this. Now, what happens is we can actually use these coefficients to predict what's going to happen in a chemical reaction and how much we're going to get out of it. And this is actually the basis of all pharmaceuticals. They have to predict how much of a particular medicine they're going to be able to produce, how many tablets, based on how many ingredients they put in there. So the easiest way to show stoichiometry is to just jump right into an example. So here's the example. So right now I want you to pause the video, write down this example, and give yourself a little bit of space because I'm going to write it out very similar to the way I did it in the mole, where I'm going to show you how to set it all up, and I'm going to put a lot of arrows to where everything goes and what it means. Okay, so now that you've paused the video, and you've written down the example, let's go through this. It says how many grams of carbon monoxide, CO, are needed to react with an excess of Fe2O3 to produce 558 grams of iron. Now, they gave us our nice chemical reaction. So, as always, whenever we do any mathematical problem, the first thing we want to do is write down our given. Now, our given here is 558 grams of iron. How did I know that? Simple. It's the only number in the whole problem. So for right now, while it's nice and simple like that, we're going to focus in on that. So we write down what we're given, okay? And we're given grams. Now, after this, now we have to do a conversion because it wants grams of CO, but it gives us grams of Fe. Now, previously, we only worked with one substance, so we would go from grams of Fe to moles of Fe, but now we want to go from grams of Fe to grams of CO, and there is no direct conversion. So we're going to have to do this in multiple steps. So the first thing we're going to do is we're going to convert to moles. So we set up our little chart, because remember, when in doubt, mole it out. So we write down the units for our given, which is grams of Fe, go on the bottom. And then what we want. Now, we always are going to convert into moles. So we're going to convert into 1 mole of Fe. Now we know that 1 mole of Fe is equal to the weight from the periodic table, which is 55.05. Remember to round to 2 places past the decimal and stop. Okay, so now I'm in moles. Now previously, that's where I stopped. But that doesn't give me my answer because that's only moles of Fe. I need to go to grams of CO. So I'm going to move this and add on to this calculation and do this in many steps. Now, the only thing that we have that compares Fe to CO is the balanced chemical equation. So remember what I told you before, the coefficients give us a ratio between our substances. So what we're going to do is we're actually going to extend out our conversion, and we're going to include those coefficients from the balanced chemical equation. So since I'm working in moles of Fe right now, I'm going to put moles of Fe on the bottom. I want CO. So I'm going to put CO on the top. Now, what numbers go with these? Well, now I go to the balanced chemical equation. And I can see that there's a 2 in front of the Fe and a 3 in front of the CO. So what I'm going to do is I'm going to take the 2 from the Fe and put it next to the moles of Fe, and take the 3 from the CO and put it next to the moles of CO. I got mad PowerPoint skills, I got to tell you. Okay, so now I've used the ratio. So again, I'll write this all out and I'll review it all for you. So first I went from grams to moles, and I went to moles of Fe. Then I went from moles of Fe to moles of CO. Okay, but that's still not the answer because the answer wants it in grams because it says. So now I got to go one more step. So now I want to convert into the last thing that I want. Okay, and the last thing I want is grams of CO. So I'm currently in moles of CO, so that goes on the bottom. And what I want, grams of CO, will go on the top. I know that 1 mole of any substance is equal to the weight from the periodic table. So 1 mole goes on the bottom and 28.01 grams go on the top. Now, I go to plug this into my handy dandy calculator. How am I going to plug all of this in? Well, now, before it was just a simple straight up top divided by bottom. Well, actually, it's a straight up top divided by bottom too. But what I want to do is I want to do this all in parentheses. Top and bottom. Okay? So this will be 558 times 1 times 3 times 28.01. All of that in parentheses. Don't jump out of the calculator. Don't hit enter. Now just straight up hit divide. Put 55.85 times 2 times 1. Close your parentheses. Hit equals. And that will give you an answer of, I'm sorry, I have to solve, of 420 decimal grams. And the reason I put 420 with a decimal is, remember what I tell you in class, I want 3 digits once you hit your first non-zero. So this is my first non-zero, and then 2, and then not, the 0, and then the decimal tells me that the 0 is important, and I'm done. And that's how you solve stoichiometry. So let me do a quick 30-second review. So the first thing we write down is our given. Okay? Now our given happened to be in grams, so the second thing we're going to do is convert to moles. Now after we're done converting to moles, we then go into the mole ratio. And remember, the mole ratio is whatever we want goes on the top, whatever we have goes on the bottom, and that comes from the coefficients in the balanced chemical equation. And then the last thing we can do is convert back to moles. I'm sorry, convert back to grams. Now, the best part about this is I can give you a lot of different permutations of this particular problem in class. So in other words, if I give you grams, but I ask for moles of CO, well, then I would just leave off the very last step that converts it back to grams. If I gave you moles, then you would leave off the first step of converting to moles, and I would just jump straight to the mole ratio. Okay, so instead of extending out this video with a lot of examples, I put all of the examples in a whole nother video. So just go to the end of this playlist if you want to see a whole bunch more of just stoichiometry examples. Otherwise, I'm going to stop here. You shift over to doing some practice problems, and I'm going to move on to doing percent yield and error analysis.